All right, here we go. Plan for the recording is to talk through the Chapter 5 review worksheet. Hopefully you've already printed it and worked through it. If not, you can just work it off the screen, hit pause, work the problems, and so on as I work through them. It would be most beneficial if you don't just watch. It would be most beneficial if you have them done ahead of time. All right, so question 1. We're supposed to simplify this. It's a perfect cube. It's a cube root, sorry. So I'm looking for perfect cubes. So I'm going to make this, let me change that real quick. Whoops. All right, so I'm going to make this the cube root of 8 times the cube root of 2, because 8 times 2 is 16, and I picked 8 because it's a perfect cube. So now the cube root of 8 I know is 2, and the cube root of 2 I don't know, so I'm going to leave it inside. And now I'm going to use my shortcut. 4 divided by 3 is 1, so I have x to the first power out here, and there's 1 left inside, so it's x to the first left inside. 7 divided by 2 is 3, set it backwards. 7 divided by 3 is 2, and there's 1 left over. 5 divided by 3 is 1, and there's 2 left over. And we're done. Okay, number 2. I'm going to multiply first. We could try to reduce that down, but I'm going to multiply first. 40, 10 times 4 is 40. Now I'm going to ask the question, what perfect cube goes into 40? And that would be an 8. And 8 times 5 is 40. Cube root of 8 is 2. Cube root of 5 is some constant or some decimal. Okay, number 3. First thing I'm going to deal with is this negative exponent. That causes my fraction to flip over. Now I'm going to raise each 27 and 8 to the 2/3. Bottom number is my root, so the cube root of 27 is 3, and 3 squared is 9. Cube root of 8 is 2, and 2 squared is 4. And I'm done. Okay. Number 4, what's under the radical has to be the same. So a lot of times we say, so I need to try to make them the same. Well, we aren't really trying to make them the same. We are simplifying, and if they happen to be the same, then I'm going to combine like terms. Okay, so what perfect square goes into 50? Well, that'd be a 25, and that'd be 25 and 2. What perfect square goes into 8? That would be a 4. And this is already reduced, so I'm going to just leave it alone. And what I notice is I have square roots of 2 all the way across, which is good. Square root of 25 is 5. Square root of 4 is 2. I don't have an equal sign there. And minus 4 square roots of 2. 5 plus 2 is 7. 7 minus 4 is 3. All right. Negative exponent. Like we said up here, a negative exponent will take a fraction and flip it over. But I don't have a fraction. Well, I kind of do. It's 16 over 1, but the negative exponent also means 1 over the expression without the negative sign. And evaluate just like we did up here. The 2 means square root, so it's the square root of 16, which is 4, and 4 cubed is 64. So this is 1 over 64. All right. I have this square root on the bottom. I can't have it there, so I need to multiply by something to make this a perfect square. Well, 2 goes into the 4, which is the next perfect square up, so I'm going to multiply by square root of 2, not square root of 4. And what I do to the bottom, I have to do to the top. So on top I have 10 square roots of 2. On bottom I have 2. And in this case it happens to reduce. 10 and 2 reduce down into 5. So I have 5 square roots of 2. What perfect square? Nope. What perfect cube does 4 go into? The perfect cube that 4 goes into would be 8. Or the smallest perfect cube that 4 goes into would be 8. How do I make a 4 and 8? I times it by 2. And what I do to the top, I have to do to the bottom. So I have 12 cube roots of 2 over the cube root of 8, which is just 2. I was thinking ahead. And so I have 12 cube roots of 2 all over 2, which comes out to be 6 cube roots of 2. I can reduce these because they're both outside. I can't reduce these because one is out and one is in. Okay, multiply top and bottom by the conjugate of the bottom. Conjugate is the opposite sign of the irrational number. On top I get 6 minus 2 square roots of 2. On bottom, get comfortable multiplying that out quickly. 3 times 3 is 9. The middle terms go away, and square root of 2 times the square root of 2 is 2. If you need to, make your 2 parentheses, make your box, do the FOIL, that's fine. But by this time, we're in Honors Algebra 2. We're moving on into Pre-Calc and AP Calc. AP Calc test is timed, so the more comfortable you get multiplying these things, recognizing the pattern, the more it's going to help you. If you still need to go to a box, that is totally fine. Go to the box, but get to the point where you can recognize this very quickly. I'm done. That works. Okay, I'm going to multiply this out again before I reduce. 12 times 8 is 96. 96 can be broken into 16 times 6. Why did I pick 16? Because it's a perfect square. And the square root of 16 is 4. Square root of 6 is some number. Okay, if you needed to reduce this first, totally fine. What perfect square goes into 12? Well, I can make that 4 and a 3. What perfect square goes into 8? Well, again, that'd be 4. But this time it's a 2. Square root of 4 times square root of 4 is just 4. Square root of 3 times square root of 2 is just 6. Either way. Okay. Number 10, graph. Hopefully by now we've got to the point where we can graph a cubic. We graphed, what, 3 of them on the last worksheet on that first practice test. So we should recognize what a cubic looks like. We should know that this makes my cubic go right 1, and the other minus 2 makes it go down 2. From there, I'm going to graph my pattern. If x is 1, 1 cubed is 1. When x is 2, 2 cubed is 8. When x is 3, it's 27, which is way off the graph. If x is a negative 1, meaning if I go left 1, y goes down 1. If I go left 2, y goes down 8. And there's my graph. I cruise down, flatten out for a second, not that fast, and cruise on down. Okay, there's my graph. Graph the inverse. I'm going to go ahead and find the inverse. We talked about this in class a little bit. Whoops. I could just switch the x and y coordinates, but when I did that in class, some eyes got glazed over, and so I'm not going to do that. We'll just go ahead and switch the x and the y. I'm going to add 2. And now I'm going to cube root. Can we do one more step in our head? And I'm going to add 1 because that cube is now gone. And now I have y. Okay, so this makes my graph go left 2. This makes my graph go up 1. Left 2, up 1. This is a cube root function, so I'm not looking at this anymore. I'm just looking at the cube root. And so it's really just the switching of the x and the y's from what I just graphed. Now if x is 1, cube root is 1. If x is 8, the cube root of 8 is 2, whereas here I went 2 and 8. Now I'm going 8 and 2 because we switched the x and the y. If x is negative 1, y is a negative 1. If x is a negative 8, y is a negative 2. Notice these points are simply reflected across the y equals x line. You'll see it better here once I graph that. Cruise a y equals x line through here. And this is a reflection straight across the y equals x line. If yours does not do that, you did something wrong. That's a nice visual to check. Okay, verify. We must do composite functions. F of g of x must equal x, and g of f of x must equal x. So let's work it out. Take g and put it into f. So this becomes the cube root of that whole entire mess is going right there. So I have x minus 4. Why did I put a 3? X minus 4 cubed plus 2. So that I put right there for the x. Well, there's still this minus 2 sitting there. And there's this plus 4 sitting outside the radical. Plus 2 minus 2 goes away. And I get the cube root of x minus 4 cubed. Plus 4 outside. Cube root cancels. And I get x minus 4 plus 4, which is x. Just because it works here, we have not verified. We must show both. Now I'm going to take the f, which is a cube root of x minus 2 plus 4, and I'm going to plug it in for the x in the g equation. So this big mess is sitting right here. So that's my x, that's my f of x, minus 4, etc. Okay, negative 4, positive 4 goes away, and I get the cube root of x minus 2 cubed. Cube root cube cancels. Plus 2 minus 2 cancels. And again, we get x. Verify whether they are inverses. Yes. Use given functions to answer these questions. So f plus g of 2 means f of negative 2 plus g of negative 2. F of negative 2, put negative 2 right there. Negative 2 minus 4 is a negative 6 squared. It's a positive 36. Put a negative 2 right there. 2 minus a minus 2 is 4. Add them together. We get 40. This is m of a negative 2 times h of a negative 2. This is multiplication. This is not multiplication. Okay, m of negative 2 is a negative 6. H of a negative 2 is a negative 2. A negative 6 times a negative 2 is a positive 12. This is the same thing as this. So I multiply, or not multiply, I insert 2 into h. 4 divided by 2 is 2, so this is now g of 2. Put in 2 into my g equation. 2 minus 2 is 0. All right, 15. Well, I need my functions. 15, g composed with m gives me g of m of x. Take the m and substitute it into the g. So this becomes 2 minus 3x. 3x goes in for the x. Okay, inverse. H inverse, switch the x and the y. X equals 4 over y. Multiply both sides by y. And I get x times y equals 4. Divide both sides by x, because I'm trying to get y by itself. And I would get y equals 4 over x. Notice what happened. X and the y simply switched places. I have no problem with you going from here, skipping down to there. Recognizing that those can just switch places is an important trick. I don't like the word trick. It's an important mathematical property that allows you to do that. Okay, F inverse, I'm going to find the inverse of that. So I have x equals y minus 4 squared. So I square root, and when I square root, I generate both the plus and the minus. But since I'm looking for an inverse function, I don't do the minus, just because it becomes y minus 4. I add 4 to both sides, and we got our equation. Square root of x plus 4 equals y. If it just said find the inverse, which you could argue that this says just find the inverse. Yeah, it's in function notation, but if you had a plus or a minus on there for this problem, since there's no words telling you what to do, I would go for that. It says find the inverse of f of x. Okay, I can handle you putting in a plus or minus, but if you want it to be a function, then the plus is what we use, not the minus. Okay. Solve. So we're going to isolate the radical. So we're going to add 2. Square both sides to get rid of the radical. Subtract 3. Divide by negative 2. Isolate the radical. Done. Or isolate the term that has the exponent. It's done. Raise both sides to the reciprocal power. That goes away. And I get 2x minus 4. Square root of 4 is 2. Cubed is 8. Add 4 to both sides. Divide both sides by 2. We get 6. Isolate the radical. Done. Square both sides. Square cancels the square root. And like I said above, oh no, never mind, this one's different. This one becomes another x minus 3 out here. We should start to recognize that pattern also, but we'll talk about it more later. Minus 3x is a minus 6x plus 9. Quadratic. So I set it equal to 0 so I can solve. Add 1, subtract x. Factor that thing. Factors of 10 that add to 7 would be 5 and 2. Since that's a negative 7, they are both negative. What makes this 0? What makes this 0? Plug 5 in. Plug 5 in, and I get 5 minus 1, which is 4. Square root of 4 is 2. 5 minus 3 is 2. 5 works. Plug in 2. 2 minus 1 is 1. Square root of 1 is 1. 2 minus 3 is a negative 1. That does not work. And there you go. There's the review. Test on Monday. If you have questions Monday morning before school, I will be in my room. You can answer them. Or you can answer them. You can ask them, and I hopefully can answer them. All right. Enjoy your weekend.